Yeah, so good evening, beta everyone. How are you? Yeah, speak up, beta. So in this session now we are going to discuss superposition theorem. Okay? आप ही लोगों की डिमांड पे इसको डिस्कस कर रहे हैं. So what is the superposition theorem? You will tell me, then we will discuss. Okay? And at the beginning of this session, I want to tell you, beta, if you have any. Okay, so yeah. Good evening, beta. So tell me, Balak. Yeah, good evening, beta. And everyone first tell me, please. Okay, fast. What is the concept of superposition theorem and mainly in which type of circuit, beta, this theorem is applicable? Mainly in which type of circuit this theorem is applicable? Okay. Yeah. Sir, it's pleasure to see you. Yeah, thank you, beta. So here, beta, before starting this session, I want to tell you. Yeah, it is correct, beta, but the definition can be somewhat better. Okay. So yeah, oh, absolutely correct, beta, whatever you say. Okay, so if you want to take subscription in Unacademy, beta, you can use my code. Okay, and if you have any problem, you can contact me on this number, and this code will give you, beta, maximum discount. Okay, now see first the superposition theorem. Before starting this theorem, I want to ask you something, beta. Okay, everyone try to understand, beta. Here, as I told you many times, beta ji, always try to understand the concept behind your topic. Why we need beta superposition theorem is the most important question arise here. Yeah, let us assume I say beta when we have more than two sources, we can use superposition theorem. So we can handle that type of circuit by KCL, KVL also, by super mesh, super node, whatever. Okay, so you can say, sir, the most important thing when we want to identify the load power due to some different type of source. For example, beta, it is not easy to explain without circuit. So I want to take one circuit, beta, in such fashion. Okay, and it's my request, beta, if you are really serious, then listen to me carefully. And if you are not serious, then please leave this platform immediately. Okay, because seriously, I observe that many students are not serious. Okay, and here if I will speak somewhat wrong, you can comment on that, but if I will teach, I want to teach you, beta, in better way, then you should give respect. Okay, so see what I want to tell you here. Let us assume, beta, this one is R1, this one is R2, this is R3, something. And I want to ask you, beta, what will be the power dissipated by R2 resistance due to V1 only? Due to V1 only, then we can identify, beta, or then we can apply superposition. But now question arise here, beta. Yeah, really? Can we apply superposition theorem to calculate power? Obviously not, beta. It means whenever we want to identify, beta, the current contribution here, due to V1 or due to V2, only we have single choice, and that is nothing but SPT. Okay. Yeah. Now can I ask you, beta, some more thing? Yeah, please speak up very well, yeah. Speak up, beta. So see, what is the thing, beta? When we have, see, beta, when we have more than one sources in our network, and beta, let us assume it is V1, this is V2, okay? See properly, beta. When we want to calculate current contribution in the R2, we can either activate V1 or V2. So due to the V1 and V2, we can identify individual current contribution by SPT. But still, beta, according to me, it is not good point. According to me, it is not good point. Yeah, speak up, beta. Next person, please tell me. Now, beta, I want to tell you here one more circuit. And this is the circuit, beta, where we have different frequency sources. For example, beta, it is the 1, it is the 2, and this is DC sources. So beta, let us assume it is 10 volt. Yeah, Angry beta, we will discuss this thing. But before that, listen to me carefully, beta. This is the DC source, and it is the beta. I'm writing Vm sine omega t. And this is, I'm writing beta, Vm sine 2 omega t. Okay. Now, can you tell me beta, only which theorem can handle this circuit? Or beta, all theorem, all rule will handle this circuit, second one. Okay. Yeah, think over it. Can we handle this circuit by superposition? Can we calculate equivalent voltage? Can we apply beta Thevenin theorem? Can we apply beta Norton theorem? Can we apply maximum power? Can we apply directly KCL, KVL? So think over it in the second solution or second question. My dear friend, beta, this circuit, whatever second one, is operating at 3 frequencies. And what are those frequencies? I want to tell you, beta. First one is 0 hertz because pure DC signal. Very nice, beta. Because pure DC signal, this one is omega, beta. This one is 2 omega. It means, beta, except superposition theorem, no one can handle this circuit. And this is the beauty of superposition theorem. So the main advantage or the main application of superposition theorem is nothing but we can solve, beta, a circuit which is operated by more than one frequency. Which is operated by more than one frequency. Please tell me, dear, it is clear to everyone or not, beta, please. Yeah, this is the thing. Now here, beta, I want to tell you the basic idea about the superposition theorem. In a linear network, beta, when we have like n number of beta independent sources, kind of current source and voltage source. So at a time, only single source will be active and the rest sources will be deactivated. And by this phenomena or concept, we can calculate beta current through every element. Okay. And what is the advantage of it? It is nothing but we can identify the current contribution for the particular load with the help of SPT by the different sources. Okay. This is the biggest advantage of superposition theorem. And beta, when we apply superposition theorem, what we have to do, I will tell you sometime later. And the next point is, beta, when our circuit has different frequency signal, only we can handle that type of circuit by superposition theorem. Hope so it is also clear. Yeah, Sumu beta, because we cannot, why we cannot apply rest theorem? It is the most important question. See, beta, we know that everyone, listen to me carefully, beta, at this moment. It is really good question, beta. Yeah, beta, this is this thing you can say, or you can apply for the 3-phase also. There is no restriction about the supply, either it is single phase or 3-phase. Please don't worry about this thing. Okay, so you can apply superposition theorem wherever you require. Now see, beta, I want to take one example for the better understanding why we cannot use other theorem to handle that type of circuit which are operating by different frequencies. Okay. See, beta, here I want to write some RL is there, some RC is there, and beta, see, I want to apply some voltage supply here. That voltage supply, roughly, I want to say beta 100 sine 2 omega t. Okay, 2 omega t. And here, beta, we have some supply in this fashion DC and another supply in this fashion. So I want to write, beta, it is 100 omega t. And this is, beta, roughly 15 volt. So see, beta, we are not worried about the resistance mainly. We are worried about the beta inductance and capacitance. See, you know, when we want to operate our system by DC supply, in steady state, your inductor and capacitor will be short and open or short. It depends upon the type of circuit configuration. And due to beta 100 omega and 2 omega, the reactance part of L and the reactance part of C will vary. So beta XL and XC will depend upon omega. So if your omega will vary, your XL and XC will vary and your performance of system will change. And this thing beta we can consider only when one source is active at a time. One source is active at a time. And this phenomena was given by the superposition. So that's why beta only superposition is valid. You cannot apply any other theorem or concept which can give you answer of this network instantaneously or in single step. It is impossible to identify because the value of L and C beta will vary with respect to frequency. When the frequency is 0 hertz, some current will flow. When the frequency is 100 omega something, another current will flow. And the frequency is when 2 omega, another component will flow. So here beta the current content, some DC value, some second harmonic you can roughly, and some 100 order of harmonic. So all will be involved in this circuit. And this thing we cannot handle by any other except superposition. Yeah, tell me beta, it is clear or not? Yeah, one thing I observed beta, really, I explain a lot of things, but for you, all things are really neutral. You are not, sometimes I observe that you are not capable to recognize that which point was so much good and which point was average. At least beta identify this thing. Okay. Yeah. Now next thing is, yeah, dear beta, tell me any other doubt. Here beta, why I'm asking why this superposition theorem is most popular. So here beta you have to give reply when your, as I told you beta, when your circuit has more than one different frequency signals, only beta SPT is applicable. So that's why it is most popular, not by any other region. Please mind it. Now next thing is beta, I want to tell you here. At the time of applying beta superposition theorem, what is the most important point beta? As I told you many times beta, again I am repeating, which is different frequency of independent sources can be handled by only SPT. I'm writing all the points so that you can take a screenshot and you can read these points after the completion of this class. Okay, and this is the another point. Okay, now here beta, procedure to apply superposition. Let us assume beta our network has, yeah, good evening beta Pawan. Now listen to me carefully beta, how we can or we apply SPT superposition theorem. Let us assume beta our network has n number of active elements, and active means only independent we are considering. So at a time only one independent source will be active, and according to that you can apply your basics law of circuit theory. For example beta KCL, KBL, supermesh, supernode, etc. Okay, so all these things beta here like mentioned. And the most important thing, as I told you in the basics of circuit theory lectures, that beta dependent sources are not the part of kind of independent element. So never beta replace your dependent sources either by short or open at the time of applying superposition theorem. It's my request beta, please mind it, when you will apply superposition theorem, your dependent sources beta will be unaltered. Sorry beta, your dependent sources, yeah, somewhere here written it is your dependent sources will be unaltered, means will not change or replaced by short and open. And only beta independent sources will replace by short and open. Why short and open we have already discussed. So your voltage source independent will replace by short, and your current source independent will replace by open. Now tell me beta, till now whatever I teach, it is clear or not? Yeah, speak up beta, please everyone. And bola kariye beta, please. Now next thing beta, current and voltage calculation by SPT. Yeah beta, please mind it. We don't have any restriction about the, listen to me carefully beta. We don't have any restriction about the superposition theorem with respect to calculation of current I and calculation of voltage V. Sometimes beta, please listen to me carefully. Sometimes beta, the current calculation and the voltage calculation is not possible by superposition theorem. I will tell you in which cases. In some special cases beta, superposition is not applicable to calculate current and voltage. But these examples will considered at beta ideal examples, okay? And in practical life, this thing will never applicable. So in practical system, our superposition never have any restriction about the calculation of voltage and current. Please mind it. बहुत बड़ी बड़ी बातें हैं, पता नहीं आपको छोटी लगती होंगी, but as a teacher I want to say beta, in general persons are not aware with this thing. So please try to understand what I want to tell. I want to tell beta, sometimes current and voltage calculation is not possible by superposition theorem. But beta, in practical life, superposition theorem will never fail for the calculation of current and voltage. In ideal network, in some situation, that theorem may not be applicable. Okay? So just keep in mind this point. Very nice beta. Sir, मैंने आपका ट्रांजिएंट के वीडियो देखे, बहुत हेल्प रहा सर, ऑलमोस्ट क्वेश्चन का. Okay, thank you beta Pawan. Yeah, what is the doubt beta? Yeah, Karimullah, so doubt is yeah, I'm not getting. Yeah, okay sir, if the dependent sources depends on short circuit sources, what happens? Yeah beta, in that case you can make short or open. For example, I want to say beta, suppose one dependent source is given in the circuit beta, one dependent source is given in the circuit, and let us assume something like this beta is our circuit. So this is the plus minus and it is the beta R, and again we have some R, and here beta I have some this one beta voltage source, okay, and I want to write beta this is the one more voltage source here also, okay, something like this, and one resistance. Let us assume beta this value is 2I1 and I1 is given here beta, and we want to apply superposition theorem for the V1 and V2. It means beta I1 is 0. So in that situation, your this dependent voltage source will be short circuited. Okay, so there is no big issue. Whatever your properties will satisfy, okay, whatever your property of the circuit will tell, you must apply. Okay, but let us assume beta this I1 is not going to 0, then you are not supposed to make this dependent source either short or open at any cost. Okay, yeah, hope so it is clear to everyone. Okay, yeah. Now beta, this is the thing. Now beta, calculation of power heat loss by the superposition theorem. I want to tell you here one most important thing beta. Can you tell me one thing beta, please try to understand. I proportional to V is a linear equation or non-linear? Speak up beta, please fast. I proportional to V or V, I want to say beta V is equal to IR will be the linear equation or non-linear. And the second question for you beta is coming, psi is equal to Li, where psi is flux linkage, or you know beta VL is equal to L di by dt when your inductor is initially uncharged, will be linear or non-linear. Similarly beta, third equation I want to write Q is equal to CV will be linear or non-linear. First tell me beta, these equations are linear one or non-linear one? Yeah, please speak up. Where are you beta ji? Yeah. So see beta, I proportional to V or psi is equal to Li or Q is equal to Cb, all are linear equations. Please mind it beta, all are linear equations. It means the most important point beta, we can calculate current or voltage. Please mind it beta, we can calculate current or voltage. Yeah, very nice beta, linear one. We can calculate beta current or voltage. Yeah, thank you. We can calculate beta current or voltage of resistor or inductor or capacitor or beta dependent sources or beta independent sources by superposition theorem. क्या मैं कह रहा हूं? Are you getting my point beta? We can calculate beta current or voltage of resistive element, inductor element, capacitor element, dependent sources, independent sources by superposition theorem. We don't have any restriction. We don't have any restriction. Okay? Here beta, I want to tell you one more thing. What is the resistive power? Can you tell me beta? What is the resistive power? Let us assume beta here R, this is the I and this is the V. By Ohm's law beta, we can write V is equal to IR. And beta, you know very well I is equal to V by R is also because proportionality is there, I proportional to V. And due to this reason beta, if we will write P is equal to VI, we can also write V square by R and I square R. Okay. Now tell me beta, this first term and second term or this third term are linear one or non-linear one? Speak up everyone beta. Yeah, I square R beta and V square by R will be linear one or non-linear one. Okay, this is the question. And the second thing beta, I want to tell you, yeah, very nice beta, very nice. Second thing I want to tell you beta, if we have some V here, Vs and Is beta. So tell me here, if the I is variable, see beta, V will be variable. If I is constant beta, V will be constant. It means beta, whatever changes will come into I, same changes will come into V also. Okay. So beta here, that's why we are writing V square or I square, and it is non-linear equation. All of you are correct beta, non-linear. Now see beta here, when beta we want to write Vs Is, this Vs is independent quantity, will not depend upon the variation of Is. So see beta, this Is, please mind it beta, this Is can be linear, please mind it, or can be non-linear. It depends upon the circuit configuration. It's my request beta, doesn't matter one student present or two student present. Matter is that whoever present is getting or like getting my point or not. It's my beta promise from my heart or bottom of heart. See beta, the most important thing I want to tell you, nobody will tell superposition theorem in that much of depth. It's my challenge beta, you can accept this thing, and you can give me any book or any YouTube video or any video, sir, yeah, that person taught far better than you. Okay, so it's my overconfidence, you can say beta. So please try to understand whatever I want to tell you and be serious. This beta, Is current can be linear or non-linear. The most important thing beta, here your I can be linear, your V can be linear, but the multiplication will always be non-linear. Please mind it, the multiplication will always be non-linear. Doesn't matter beta what is the thing here. So see beta, the power, okay, the power will be non-linear quantity. And here beta, current linear or non-linear. So first always identify whether current flowing through the battery is a linear one or non-linear one. If this current is non-linear, stop your solution by SPT and follow any other method. Okay, so just keep these 2 points in your mind. Here beta, I want to tell you another thing. The SPT superposition theorem is valid only for the linear network, not for non-linear. When it is valid for non-linear, I will tell you. But please, whenever you are sitting in the good interview, for example, beta IAS, IES, and GATE, only beta in these 3 interview, not any other place. Okay, because I know professor, how much professor has knowledge. So see beta, only some reputed places. Okay, for example, you are sitting in the IES interview, IES interview, or GATE. You can say beta, your superposition theorem can follow for a small non-linearity also. A small non-linearity means non-linearity will almost be negligible. Okay, for that you can take this source beta, William Haight, which is very standard work. It will tell you something, and we will also discuss, okay, sometime later. So please mind it, still our SPT is not valid for non-linear. Okay, just keep in mind. Yeah, now beta, tell me this thing is clear or not first, then we will discuss rest thing. So see beta, here once your power you want to calculate this V square by I square R something by superposition theorem, it is non-linear quantity, so you will not receive any answer or correct answer. Here beta, your IS whatever delivered by the current voltage source, if this IS is non-linear, stop your solution and follow any other method to handle this circuit. Hope so it is clear to everyone. Okay, now beta, I want to tell you another thing here. Beta, resistive power or heat loss, both are same thing beta. Resistive power or heat loss cannot be calculated by SPT. Please mind it beta, because heat loss is a non-linear quantity. Okay, see every point I have mentioned so that in future you will not get any problem. And here if you will finish your superposition theorem, then in your future you don't require any other source for the, at least for the beta superposition theorem. Okay, This is my code beta. You can use this code for the subscription of Unacademy, either 1-year program or 2-year program. If you have any doubt beta, you can contact me on my number. It will give you beta maximum discount. Okay, now beta, I want to tell you another thing. Calculation of power of independent sources by SPT. First tell me beta, this thing is possible or not possible? See the beauty of a statement yaar. Now it is possible or not possible? The calculation of power by superposition theorem of independent sources. Yeah. So SPT we calculate reactive power is possible. No beta, please mind it. It is not possible. It is not possible at all. Yeah. Very nice beta. Rushikesh, very nice. So here again I want to ask you one thing beta. When we want to calculate independent sources power, we can apply beta superposition theorem. So please mind it, superposition theorem is invalid only to calculate power of resistive element. Why power of resistive element? Because beta this quantity, power quantity P is equal to I square R will be non-linear. One more thing I want to tell you. For all the independent sources beta, for the calculation of power of all the independent sources, SPT is not valid. SPT is valid to calculate the power of beta independent sources only when beta individually your V and I, voltage and current of that particular independent source are linear. If one of them is non-linear, your this concept will be fail. You are getting my point or not? Please tell me. बातें कुछ बड़ी हो सकती हैं बेटा, बट ये वादा है कि इससे बड़ा अब कोई नहीं पूछेगा. ओके, इसीलिए एक बड़ा अजीब सा शब्द लिखा था मैंने फेसबुक पे कि चरम तक इसको सीखते हैं. चरम का मतलब होता है पराकाष्ठा. ऐसा एक शिखर बेटा जिसके बाद कोई चोटी ना हो, कोई ऊंचाई ना हो. हम वहां तक की बात करेंगे. ओके, सो प्लीज try to understand each thing, and if you have doubt you can ask beta very times. Yeah, thank you. now beta, next thing is there, and I will prove all these things beta by some example also. Just wait and watch. Now beta, restriction of SPT. What are the restriction? I told you beta. First restriction, if we have only single source in the network, we cannot apply. If the non-linear, we cannot apply. Like this beta. One more thing is there. What is this thing? I will tell you. See beta, it cannot give correct information for voltage and current in some special circuit beta, such as, this is the most important beta point, when more than one independent ideal voltage sources are present in parallel. Why? I will tell you. Similarly beta, when more than one independent current sources are present in series. Okay, in these two situations beta, ideal, see the wording beta of my sentence, उतनी अंग्रेजी अच्छी नहीं है बट मैंने पूरी कोशिश की है बेटा. आइडियल एंड आइडियल, सी आइडियल वर्डिंग I am using. So please try to understand this statement. And power dissipated by resistance cannot be calculated. We have already discussed. So whenever our SPT will fail beta, whenever we have two voltage sources in this fashion, and rest circuit I am not drawing beta. If two voltage sources in this fashion are connected, we cannot calculate current or voltage of any element by SPT. But condition is that beta, your V1 and V2 must be ideal. Your V1 and V2 must be ideal. Similarly beta, if you have two current sources in the series, and your current sources are ideal, that means I1 and I2 are ideal, again your SPT will fail. Hope so it is clear beta. Please speak up, tell me. Yeah, thank you beta. Yeah, Karimullah beta, just send me friend request. The Facebook is nothing but engineer Ravi something. Okay, and there will be my photo also beta. Yeah, definitely beta, Pawan, good. The concept is much helpful in the yeah, thank you beta. So this is the most important point beta, whatever I told you. Now next thing beta we will discuss sometime later, and here we are discussing first example of our. Now beta, I'm not interested to take this example at this moment. Okay, so I want to skip this example and I want to tell you a few concepts with the help of examples. Then we will discuss that type of lengthy examples also. This is our first example, beta. Listen to me carefully first. Calculate, beta, please mind it, beta. Calculate the current through this resistance 10 ohm by KCL, KVL. Be serious, beta. Please forget about this question. भूल जाइए इसको बेटा, भूल जाइए. This is not question. I want to ask beta, current through 10 ohm either by KCL or by KVL or by Ohm's law. So KKO, KVL, KCL, Ohm's law. Please everyone speak up beta. What will be the current I by KVL, KCL or Ohm's law? Yeah, speak up please beta, everyone. बिल्कुल बेटा यार, मेहनत मेरी पूरी बर्बाद करवा देते हो. आप समझ नहीं सकते हो कि मैं किस लेवल से खेलने आता हूं, और जब भी आता हूं वो पिच नहीं मिलती बेटा मुझे जिस पे मैं सही से खेल पाऊं. ओके, आप लोग साथ देते हो, आई अप्रिशिएट दैट थिंग, बट आई नीड रिस्पॉन्सेस बेटा एट ऑल टाइम. ओके, सो सी फर्स्ट टेल मी बेटा I 10 ohm by KKO. This is the first question for you. And the second question, my dear friend, same. Calculate I 10 ohm by superposition theorem. So what is the first answer beta? Tell me. Yeah, very nice. बेटा मैं कंटाप मार दूंगा. करीमुल्ला, कंटाप समझते हो ना? Slap you. See बेटा, how can you write 20 ampere? See बेटा, in the series, it is series circuit or parallel one? Yeah, speak up बेटा. It is series circuit or parallel one? Yeah, it is series circuit or parallel one? यार ऋषिकेश, मैं सुसाइड कर लूं क्या? बोलो. अब जिंदा रहने का हक नहीं है यार मुझे. मैं फैक्ट बता दूं. बहुत मारेंगे कंटाप खींच के वे. See beta, this is the 10 ampere. This is the 10 ampere. How you can add yaar? You are not supposed to do this type of silly mistake beta. मैं इसके लिए क्षमा नहीं कर सकता. Okay. So this is a 10 ampere beta. This is a 10 ampere. So by KCL, KVL or Ohm's law, this current I will be 10 ampere. Okay. So this current beta will be 10 ampere. Okay. Obviously yaar, in the series circuit current cannot change. Okay. So this is kind of series with respect to current beta, because everywhere we have current only 10 ampere. This is the first thing beta. So by KVL, KCL and Ohm's law we are getting 10 ampere current. But my question is not that one, you know very well. My question is somewhat different one beta. My question is that calculate this I beta by superposition. By superposition theorem. How many independent sources are available beta? 2. So I want to write like this, I1 and I2. One job is done. Very nice beta, very nice. So what will be the this I current beta? See, one time beta this I1 is active. When your I1 is active, I want to write like this beta. When I1 is active and I2 is deactive beta, the current source will replace by their own resistance, and its resistance is infinite. It means the value of current will be 0. So it will be beta open circuit. It is not easy to remove this thing, so please mind it. It is open circuit. And when your current source beta will be open circuit, how much current will flow? 0 ampere. So see beta, in this particular case, this current I want to mention I1. So I1 will be 0 ampere. No need to provide direction because the magnitude is 0. What will be the second case beta? In the second case, we can say I2 is active and I1 deactive. So now beta, it is the open circuit. This is the beta active one, but still your current is 0 ampere. I want to write this one is I double dash. So I double dash beta will be 0. So therefore by SPT, just add both currents. So I is nothing but beta I dash plus I double dash is nothing but beta 0 ampere. Hope so it is clear. Now tell me beta, superposition will fail or not? Everyone speak up beta. Superposition is fail or not? Yeah, think over it and tell me beta, superposition will fail or not? Speak up please. Yeah, very nice. Now please mind it beta, never say. मैं जब बोलता हूं ना बेटा तो बहुत ध्यान से सुना करो. मैं थोड़ा अपने आप में घमंडी बन गया हूं, और इसलिए बन गया हूं बेटा जी कि मैंने ये देखा है कि किस लेवल की सुपरपोजिशन होती है. तो अगर मैं डिस्कस कर रहा हूं तो जब मैं बोलता हूं ना, वर्डिंग को ऐसे कैच किया करो जैसे मान लो भगवान कृष्ण कुरुक्षेत्र में खड़े होके अर्जुन को गीता का उपदेश दे रहे हैं. ओके, उस तरीके से सुना करो. क्या मैं बोलने चाह रहा हूं सुनना बेटा. सुपरपोजिशन थ्योरम is never invalid. superposition theorem is never invalid for the calculation of current and voltage if current and voltage are linear quantity, or in other words beta, your circuit is linear. Why here superposition theorem is invalid? The reason behind it is nothing but your current sources are ideal one, and practically beta we don't have any ideal current source. Practically we don't have any ideal current source. Please mind it beta, in practical system superposition theorem does not have that type of restriction. So it is always applicable for voltage and current, but unfortunately it is fail on books beta, on copy by pen something beta, in ideal cases. And in practical life we don't have ideal life, we don't have beta ideal cases. Okay, so see, in practical cases beta, this will offer some resistance, it will offer some resistance beta. When you will deactivate your current source, some current will flow in this fashion and your circuit will complete. Okay, so now tell me beta, it is clear or not, please? Yeah, now I want to ask you beta another thing. Yeah, very nice. Now I want to ask you beta another thing, please. Again I need your help, I need help from your side. See beta, here I want to remove this solution. Just wait a minute beta, just wait a minute. Okay, now beta I want to consider some resistance here R1, and that is very high resistance. I want to write beta 10k, and this is beta another resistance beta, this one, and I want to write beta again 10k. Okay, then can 10 kilo ohm, 10 kilo ohm. Now beta tell me, can we calculate this current I through 10 ohm by SPT? Be serious, जब तक मेरे साथ बैठे हैं ध्यान इधर उधर नहीं होना चाहिए बेटा. So now tell me, by SPT, what will be the amount of this current? Now it is applicable or not? Yeah, think over it and tell me beta. Okay, so I am receiving beta few answers, and that is nothing but now we can calculate. Okay, I want to do this thing beta. Let us assume we have, very nice beta, yeah, very nice. Listen to me carefully first. Now beta again I want to assume it is I1, this is I2, and these are the parallel resistance, these are the parallel resistance. So see beta, here when our I1 is active and I2 is deactive, listen to me carefully beta, in this fashion your 10 ampere will flow, and this whatever this 10 ampere beta is deactivated, so current will flow in this fashion. I want to say like this beta, let us assume these are not practical current sources. I want to say beta, this is the ideal current source, and we have connected one beta resistance in parallel nature. This resistance is external resistance. So now see beta, you know very well this 10 ampere current cannot be stopped by any value of resistance except open circuit. So it is still beta 10 kilo ohm. So same amount of current will flow, 10 ampere, 10 ampere, 10 ampere, 10 ampere in this fashion. How much beta this I dash value will come when your I1 is active and I2 will be deactive? Think properly, try to understand and tell me beta, what will be the I1 dash when I1 is active and I2 is deactive? Yes, speak up beta. आज भी वो माहौल नहीं बन पाया बेटा जो मुझे चाहिए था. कोशिश करो यार 10-5 दिन में इसको बेहतरीन बना दो, ताकि उस लेवल की हम बातें कर पाएं जिस लेवल की मैं आपसे करना चाहता हूं. या नो बेटा करीमुल्ला, never say this thing. Whatever I said earlier, that was the different thing. I'm not saying beta that statement is valid here. Why you are adjusting the circuit according to your choice? Who are you beta? You are just a human being. You don't have power to change the circuit situation. Once you finalize your circuit, you will excite your system. Nobody can change the performance of this system beta without using external equipments. We are not using such like equipments beta. So see, this beta current source value will be 10 ampere and will constantly flow in this fashion, yaar. So the I dash value will be 10 ampere. Why you are worried, yaar? Why you are worried? You're not supposed to do this thing, beta. Now see, beta, in this case, when our I2 is active and I1 is deactive, this current, beta, this current, because this 10 kilo ohm resistance is, beta, is very high in comparison to 10 ohm resistance. Okay. So see, I want to tell you in this fashion how much current, beta, will flow in this way. See, beta, this is the current source parallel resistance. This is the current source parallel resistance. Both are connected in series. Okay. So see, beta, when you will consider parallel resistance, and let us assume some 10 ampere current is passing here, beta, and when your this 10 ampere current source is deactivated, obviously the path will be this one. Now, obviously the path will be this one. Similarly, beta, for this, the path will be this one. Okay, this one. So why you are worried, beta? This 10 kilo ohm or 100 kilo ohm cannot change the amount of current. Okay, leave it. I want to give you one example and tell me what will be the value of current. Beta, here I want to write it is the 10 ampere current, and here, beta, this is the resistance. Okay, and again, beta, I have some resistance which is nothing but this one only, and here, beta, it is grounded. This is open one, and here it is grounded. So, beta, it is the 10 ohm. It is the 10 ohm, beta, and it is the 10 ohm. Okay. Now, beta, can you tell me the value of I in this circuit? Everyone, tell me, beta, the value of I in this circuit. Yeah, speak a bit fast, please. The value of I in this circuit. Yeah, first tell me, then I will consider next point. The value of I in this circuit. So see, beta, the value of I in this circuit will be how much? 10 ampere, because, beta, this amount of current will not change. So this value will be 10 ampere. Now, beta, what will be the value of this current I, this one I, beta, when your this resistance is 10 mega ohm? Yeah, I'm waiting for your response, and I will not reply, beta, answer of this question. When value is, beta, I want to write like this, when this is R, beta, and this is I, beta. When the value of is R is 10 ohm, the value of current is 10 ampere. And the value of when R is, beta, 10 mega ohm, what will be the value of I? Yeah, everyone, beta, please speak up. What will be the value of I? When our resistance is, beta, 10 mega ohm, this R is 10 mega ohm, what will be the value of current I? Yeah, very nice, beta. It is still how much? Yeah, beta, it is still how much, beta? 10 ampere. It means, beta, value of this resistance when your one source is deactivated is not going to change. It's not going to change. So still, beta, current is 10 ampere. So in second case, beta, I dash is nothing but 10 ampere when your, beta, I2 is active and I1 is deactive. What is the opinion of this, beta? In both cases, current is flowing in upward direction. Okay. So what will be the I actually is nothing but, beta, I dash plus I double dash. Okay. So now see, beta, practically this current will be 10 plus 10 is nothing but 20 ampere. Okay. See, beta, what is happening? The current is not coming correct, beta, because by KCL and KVL we have handled, beta, that current was 10 ampere and it should be 10 ampere. It must be 10 ampere. How can it be, beta, 20 ampere? Okay, this thing. So see, beta, in this situation, the circuit is not correct. Okay, or the circuit, beta, is not satisfying superposition theorem. So see, beta, please, in the practical life, we are not designing that type of circuit in which, beta, two current sources are connected in series. And if we want to design, then we want to design that type of circuit to improve the voltage level. To improve the voltage level. Please mind it, beta. So here, at any cost, beta, the superposition is not applicable. But still, the statement is nothing but, beta, SPT is valid for the calculation of current and voltage. And that is the special case. So in this particular case, your superposition is not valid. Doesn't matter your circuit is ideal or practical. But in practical circuit, beta, if you require any other resistance, for example, parallel or series, and the resistance of these values, beta, will be very small, then you can say, beta, some current will divide in this fashion also. But here it is not happening because, beta, this value of resistance is very high. Please mind it. And practically, beta, we don't have such type of circuits also. Yeah, please speak up, beta. It is clear or not? Yeah, again SPT fails. Very nice, beta. Always try to understand the conclusion. if you are not getting conclusion beta, you will not be good student to crack the gate. Okay, so see, circuit situation will tell you whether SPT will valid or not valid. So in both cases, whatever we have discussed, I want to tell you beta, like with a fact, in both situation, either 10 kilo ohm resistance present or absent, our SPT will be fail. Hope so it is clear. Yeah beta, nice. Now I want to ask you another thing beta. Example is this one. Calculate current through 5 ohm resistance by the superposition theorem. Calculate the current through beta 5 ohm resistance by the superposition theorem. Yeah, please speak up beta. By the superposition theorem. So first beta, forget about this superposition theorem. Everyone will provide beta full concentration. Please, I want to take beta one ground, and I'm not interested with superposition theorem because beta the frequency of both signals are same. The frequency of both signals are same beta. If the frequency of both signals are same, we can easily handle KCL, KVL and Ohm's law also. So here beta, I want to calculate I of 5 ohm by beta KKO, KVL, KCL or Ohm's law. Can you tell me dear, what will be this value of current I by KVL, KCL or Ohm's law? Yes, speak up beta. Again beta, you are not telling the truth beta. Yeah, speak up. Many persons are available in the today class beta. Yes, speak up please fast. What will be the value of current I beta in this case? Not by superposition theorem, NOT, not by superposition theorem, by KKO, KVL, KCL or Ohm's law. Yeah, speak up beta please. 2 ampere. Yeah, answer is not 2 ampere beta. What will be the answer? Can you tell me? What will be the answer beta? By KKO. So I won't write beta, this is the I, and I of 5 ohm by KKO will be, yeah, so 2 ampere by KKO. Okay, thank you. So it is somewhat popular now, it is KKO. So see beta here, with respect to ground, how much voltage will appear here beta? 10 volt. So beta here 2 ampere, here 2 ampere. So answer will be 4 ampere. Now tell me, it is clear or you have any doubt? Tell me fast beta. This thing is clear or do you have any doubt? The answer is beta 4 ampere. Yeah, speak up beta, speak up fast. Now I want to ask you one more important example beta. Again, one most important question again beta. Can you tell me the value of current I1 and I2 by KKO? The value of current I1 and I2 by KKO. Yeah, tell me beta. Yes. So it means you are getting my point beta. No need to ask anything. Your answer was absolutely correct. Okay. I was just testing you because in the previous example, you told me Balak that sir, the current will be 20 ampere. So that's why beta in this beta example, I wrote incorrect answer. Okay. So this is not correct one beta at all. You know very well, and never accept anything beyond your formulas. So what is the Ohm's law beta? Ohm's law is nothing but potential difference by resistance. What is the potential difference beta? 10 minus 0 by 5. So this current is nothing but 10 by 5 is 2 ampere. Very nice beta. Okay. Yeah, thank you. Now beta, I want to ask you another thing, and that is nothing but beta, tell me I1 and I2, if both sources are ideal, this 10 volt, that 10 volt, both are ideal. Please speak up. What will be the value of current I beta? Sorry, I1 and I2. I1 and I2. Okay. So Rishikesh beta, actually in the previous example, you and everyone, I'm not talking about you beta. Yeah. So Jitendra, yes. Yeah. So Karimullah, I'm not teaching maths beta. So I'm enjoying this 2-day session. I'm really enjoying beta. So very nice. So now everyone beta, see, at least you have to do hard work similar to Jitendra Kumar. He is my favorite student beta. Okay. So now see here, I1 and I2 are nothing but beta 1 ampere to satisfy KCL. As I told you beta, this network and that network, whatever, these two are ideal one. Okay. So how much current beta will flow here? 1 ampere and 1 ampere. So what is the requirement of your load will fulfilled by beta 2 sources with respect to 50% and 50%. If you belong to beta electrical core, then you know very well we use parallel connection of alternators and parallel connection of transformer to improve the rating of voltage and kVA. Okay, so this is the thing. Now here beta, I want to ask you the same thing, current by superposition. Okay, just give me a few seconds beta. Yeah, the current I by SPT. Yeah, everyone tell me beta fast. The current I SPT. Okay, yeah, think over it and tell me beta fast. Yeah, Anupam Shukla beta, wait a minute. Yeah, by okay, okay. 4 ampere is not in beta. 4 ampere, please don't discuss about the 4 ampere. 4 ampere was incorrect answer. I told you 2 times, 3 times. और क्या मैं जान दे दूं अपनी बे. So yeah, not possible, not possible. Very nice, beta. I want to ask you, this circuit or beta superposition theorem is valid in the practical case or not? Think over it. Now, beta, in the ideal case, let us assume it is the V1 and V2. Without beta wasting our time, I want to tell you directly. When your beta case 1, when your V1 is active and V2 is deactive beta, so it will be short circuited like this. No current will flow through this 5 ohm. So beta, in this case your I 5 ohm will be 0 ampere. Now what about the second case beta, when this is active, so V1 deactive and V2 active, again beta it will be short, so I of 5 ohm dash will be 0. कुल मिला के बेटा I की वैल्यू 0 एम्पियर होगी अगर SPT से हैंडल करें तो. Okay, so Rushikesh beta, I will not do any joke with respect to your calculation. Okay, now it is okay for you? Yeah, sure. So sir, I think when you said that 4 ampere how, and I think where I do wrong. Okay, it is just part of fun यार. ऋषिकेश बेटा जी, लाइफ में ना सब कुछ एक्सेप्ट करना चाहिए. कभी जोक, कभी सीरियसनेस. बहुत ज्यादा सीरियस हो जाएंगे पढ़ाई में तो थोड़ी सी दिक्कत होने लगती है ना. इतना सीरियस होके क्या करना बेटा, जंग थोड़ा जीतनी चाइना से, हमें तो पढ़ना है बस. ओके, और हमें रेडी रहना चाहिए बेटा कि अगर किसी ने 4 बता भी दिया है तो मतलब उसके साथ फाइट करेंगे. अपना भाई जितना बेसिक है उसको स्ट्रॉन्ग रखे. ओके, so see beta here, now this is the first case. Second case beta, I want to calculate I by again beta by SPT, but in the practical cases. What is the practical case? Now I want to use beta one resistance. Internal resistance is nothing but beta 1 ohm, and this is another beta 1 ohm resistance. Now tell me beta I by superposition. This is the 1 ohm, this is the 1 ohm. I by superposition. So see beta, let us assume it is deactivated. V1 is deactivated and V2 is activated. In that situation, we will see beta whether superposition is valid or not. So be serious, everyone beta, be serious please. Here I want to write first point beta. Please see here. When our V1 is deactivated and V2 is activated, what will be the value of beta this I dash? I want to write I dash beta. I dash is nothing but, see beta, 10 volt, 1 ohm and 5 ohm and 1 ohm. So see beta, what will be the equivalent resistance? I want to draw a circuit in this fashion. This is 10 volt beta, 10 volt. Here we have 1 ohm beta. Here we have 5 ohm beta. Okay, and yeah. Just wait a minute beta. Actually battery is connected opposite side, so that's why I want to give you same picture so that confusion should be 0. So this is beta 1 ohm, this is 10 volt, this is 5 ohm beta, and the last resistance is 1 ohm. So 1 ohm, 1 ohm and beta 5 ohm, and this one is beta 10 volt. Okay, now can you tell me beta what will be this current I, everyone? Not I dash beta, I want to ask this IA, whatever. IA, can you tell me beta fast? IA, only IA beta, very nice. So 5 and 1 and this beta plus 1, very nice, 10 by answer. So it will be beta 5.45. Please match, I'm not good in calculation beta. 5.4545 ampere is correct or not? Please everyone tell me beta, is correct or not? Okay, so this is the first way beta. Now what will be the current here beta? I want to ask this current or this current. So it is I dash. What will be the I dash? I want to write here beta. I dash is nothing but beta this current into opposite resistance divided by overall. So into 5 divided by beta 6, it will come beta, yeah, it will come 4 point, and yeah, so 5.4545 into beta 1 divided by 6.90. Yeah, thank you beta. Check this current beta by current division rule. It will come 0.9090 ampere. Check it beta. I'm not sure whether my calculation is correct or not. So I dash, yeah, thank you beta Jitendra. Yeah, Jitendra रहता है तो calculation पे ध्यान नहीं देना होता है. So this I dash beta will be this one, and we are interested only in I dash beta, this one. Now I want to tell you another thing beta. So here beta, in this case our V1 is active and V2 is deactive. So what will be the circuit beta? You do calculation fast. This is the R, this is the another R beta. So here this is beta 10 volt again, and this is 1 ohm beta, this is 5 ohm, this is the 1 ohm. Okay, and the same circuit is there. So how much current beta will flow? It is nothing but beta, yeah, 5.4545. 5.4545. Then tell me beta, the answer will be same, I think, according to me also. Beta, see, same circuit is there. That side and this side both are same. Okay, so this is the beta 5.45 something. So this current beta will be 0.909 ampere. I'm following your answer. Okay, so what will be the beta current this I double dash? So what will be the I by I of 5 ohm beta by SPT? Please mind it beta, by SPT it is nothing but beta 9.09 into 2. I want to write beta 1.818 ampere. Yeah, tell me, it is correct or not beta? Yeah, speak up beta fast. It is correct or not? Yeah, thank you. Now beta, see, this is the thing, and everyone beta handle this last case and tell me the current due to this thing beta. 1, and this is the, so beta 5 ohm, and this is 1 ohm, this is beta 10 volt, and it is also beta 10 volt, and this resistance is 1 ohm. Tell me beta this V. Okay, what will be this V? So by KCL we can write beta V minus 10 by 1 plus beta V minus 10 by 1 plus beta V by 5. Everyone beta tell me what will be the value of V. Yes, speak up, speak up. So it will be beta 1 plus 1 and plus beta 0.2. So 2.2 and 20, 20, right? So 20 by answer 9 point something divided by 5 will come, yeah, same. So beta this I by KCL or KVL or Ohm's law, KK, anything beta, this I will be same, and that is nothing but beta G, this 1.818 ampere, and that value is nothing but beta this V, whatever this V will come, V by 5 ampere. So see beta, in this particular case, in practical case, your SPT is valid. Now tell me beta, it is clear or not? Jitendra? Yeah. So beta, see, in the practical current sources, that circuit was not valid, or that SPT was not valid beta, but here it is valid. Okay. Now think over it beta and try to understand all those things. And yeah, and beta, be serious Jitendra. Beta, please mind these statements, whatever I have told you, and maybe these statements are very, very useful for interview point of view. Okay. And the last thing beta, tomorrow we will discuss rest properties of superposition theorem with the help of examples only. Okay, so be ready for the tomorrow class. And beta, one more thing, tomorrow class timing is 8 p.m. please mind it beta, not 7 p.m. tomorrow class timing 8 p.m. and at 7 p.m. beta, we will discuss how to cover circuit theory for more than 90% marks. How do we cover beta circuit theory for more than 90% marks? That session timing beta will be only 20 minutes. I will not waste your time. So within 20 minutes beta, we will discuss depth of the circuit theory. How we, depth means beta, how we can complete this circuit theory for getting more than 90% marks in the GATE exam. And sorry, I cannot say 100% marks, because even I'm not sure I can achieve 100% marks. Okay, even in this world, whoever present, nobody is sure about the 100% marks. Okay, 100%. You can say when you are capable to observe the paper only. Okay, बिकॉज बेटा कोई भी बंदा या कोई भी पर्सन 100% कभी सही हो ही नहीं सकता है। बड़े बड़े प्रोफेसर नहीं होते हैं बेटा, नासा के लोग नहीं होते हैं, बट हाँ इतना वादा कर सकते हैं आपसे कि 90% से ज्यादा मार्क्स अगर आप मेरे कहे मुताबिक पढ़ते हैं तो 100% आएंगे। और नेटवर्क और कंट्रोल और ऐसे सब्जेक्ट में अगर 90% क्रॉस करते हो तो डेफिनेटली बेटा रैंक अच्छी आने की पूरी उम्मीदें बढ़ जाती हैं, क्योंकि फिर बात जाके फंसेगी कोर पे। कोर को भी हम हर तरीके से हैंडल करेंगे, चाहे आप ईसी से हो चाहे आप इलेक्ट्रिकल से हो। ओके, तो थैंक यू बेटा एवरीवन। Yeah, we will discuss beta definitely, Rushikesh, we will discuss tomorrow beta, okay, each and everything regarding to circuit theory. So the discussion on circuit theory we will start at 7 p.m. and superposition theorem will start at 8 p.m. So be ready around for 1 hour and 30 minutes for the tomorrow session. Okay, yeah, thank you beta, and if it is possible then beta like and share this video to your friends also, so that उनको भी थोड़ा बहुत फायदा मिल सके। Okay, yeah, और obviously मुझे भी दोनों चीजें। ओके, या थैंक यू बेटा एवरीवन।